Hey guys, Jimmy Vegas here, and in this mini Unity tutorial I'm going to show you how you can mass generate random objects in any Unity game. Don't forget, click subscribe button, click the bell icon as well to stay up to date with every tutorial I upload to this channel, and with that in mind, let's get to work. So generating random objects is pretty easy, and mass generating to however many you would want is a kind of cool effect that you could theoretically create doing absolutely anything. I did do a weird short video a couple of months ago on this just to demonstrate what it was, but I got a lot of people asking how it was done, so I figured why not actually make a tutorial out of it, because it's pretty cool and can be used in a lot of different ways. So before we begin, I have a scene here. So the camera itself, which is right here, is basically looking down on this area, a bit of post-processing on there as well. So I'm going to generate randomly one of these objects and then mass generate those objects. So we'll have, say, I don't know, maybe 200. So one of these objects over here will randomize and appear in our scene over by the camera. So we've got how many? 1, 2, 3, 4, 5, 6, 7. Okay, so to do this, we need to do it in C#. So obviously, we need to go down here to our project window, right-click, create C# script, and we'll just call it mass gen. Obviously, the gen short for generate. So let's open that up in Visual Studio, and while that quickly loads, I will briefly tell you how we're going to do this. So we're going to create a random range to basically select an object. We're going to randomize a position of where we want that object to be, so even more randomization there. And then we're going to use Instantiate to duplicate whatever object is defined by whatever random number we've chosen, and then we make it appear at the randomized coordinates that we have chosen. Obviously, like I said, we want to have, I think I said 200 about a minute ago, so we could theoretically have a variable for that, but we're going to use a while function. That while is going to say, while we have less than however many we want, then generate the next object until we do have that amount. So we have this right here. We don't need void update, but we do need void start, because it's all going to be done in a coroutine. A coroutine is used because we need to briefly wait for, let's say, well, in this case, we'll do it for a split second, but you could wait for a whole second. You could wait for 60 seconds. It's up to you. Remember, you can always utilize, change whatever you learn from these tutorials. So the variables we're going to use are going to be the 7 objects that we have chosen. And I'm just trying to remember what they are. So brick, barrier, pallet, blocker, barrel, spool, container. Okay. So what we're going to do is I'm going to shrink this down a little bit. And there we go. So we can see right there. So let's have public game object. And we'll start with the brick. Probably should put a space there. So we've got the brick. Next, we'll do the same. Public game object, the barrier, semicolon. Next, we'll do the pallet. So public game object, the pallet, semicolon. Once again, public game object, the blocker. And theoretically, you could use like an array for this, but I guess I'm doing it this way so we can physically see how the principle of all this is working, because that's how I like to display code. I like you to be able to see exactly the route that the code is taking to be able to get to the result that we have. So, as I said, all I'm doing here is creating a variable for each of those game objects, which are going to be the ones we randomize. So the spool, and finally the container that we have. So public game object, the container. So the next couple of variables we need are going to be the ones we randomly generate. So we're going to need the X position, the Y position, the X position, the Z position. You could randomize the Y position if you want to. I'm not going to in this tutorial, because all I'm going to do is just make them fall from a height higher than what the camera can see, so they just kind of appear and fall down. But again, you could use the Y as well, using the same principle as what we do here. So public int, and let's have X pos, semicolon. and then public int z pos. Here you would have your y position. The next one is going to be a number that we randomly generate to decide which object we're going to randomly generate. So again, that'll be public int, and we'll have object to generate. And finally, we need a count. So because we want to cap this at 200, as we've said, we need to have a count to realize just how many we have in the scene. It's always wise to cap it, because if you end up trying to create infinite objects, then obviously performance would deteriorate over time. So public int and object quantity semicolon. So the next thing we need to do is think of a name that we can use for our coroutine and create the start function for it within the start method. So start coroutine, and in brackets, let's call it generate objects. Oh, close bracket, semicolon. So because that's the name, we now need to go enumerator in a new method, or coroutine as it were, enumerator, and we'll call it, as we've done, generate objects. And open close bracket, open curly bracket. And now this is where that while comes in. So while, and in brackets, object quantity is less than 200, and this is the point where you can put anything you want. So you could put 1,000, you could put 10, you could put 5,000, 500, whatever you wanted. So however many objects you want in your scene, this is the number you would put there. You could use another variable for that if you wanted to. It's entirely up to you. So next thing we need to do is object to generate equals random.range, and in brackets the minimum and maximum. So minimum is going to be 1, maximum will be 8. Although we have 7 objects to choose from, in this instance the maximum number we put here will never generate within this random.range. It's one of them things within Unity coding. Don't worry about it. So if you have 7 objects, just make sure you put 8. If you have 20 objects, make sure you put 21. So just one above whatever your maximum is. And semicolon. So this will generate either 1, 2, 3, 4, 5, 6, or 7. Next thing, we need to generate the X and Z position. So I'm going to maximize my Visual Studio again and head back to Unity. So if we look around here, pan this around and look straight down, we know roughly where we want our objects to fall. Here, to here, to here, to here. So within this area right here. Now to measure this, a neat little way of doing it is going to game object, 3D object, and cube, and then placing that cube wherever you want your corners of your spawn area to be. So in this case, we'll have this probably about there. So we can see here the X is roughly 209 and the Z is roughly 31. So we can use that to our advantage. So position X 209, and if we bring this across to about there, 197. So 197 will be the minimum, 209 will be the maximum. So what we do here is X pos equals random.range, and using the same principle as before, the minimum range is 197, the minimum we can generate. The maximum would be 210 because the maximum we found was 209. So we're just adding 1 to that. So now let's work out our Z position. So Z pos equals random.range, and in brackets, let's now work that out. So we have 31 right there as our Z, and we want it to be roughly somewhere maybe here. So 31 and 42. So minimum 31, maximum 43, one above what we would want. So now we've generated randomly everything we need. We now need to create some if statements to say if it's this, then we instantiate this object. If it's something else, do another, and so on. So if, in brackets, object to generate equals, that's double equals, remember, because we're basically asking. If it equals 1, then what we do is open curly bracket and instantiate. And in brackets, we then need to put what object we want to instantiate. So let's do the first one, the brick, semicolon. And then we need to state the position it would be. So we'll need to use a new vector 3, and in brackets, the X, Y, and Z coordinates. So X pos, comma. If you've randomized the Y range, you would put this here. But for all intents and purposes, I want it to be somewhere above our camera. So let's have that maybe somewhere here. So let's we say 150. So we'll say the Y position is 150, which is where our cube is now. So I'm going to do that. And finally, the Z position, close bracket, and then quaternion.identity. Quaternion.identity. And this basically allows us to complete that instantiate, and everything is now working within that line of code. So close bracket and semicolon. So there's our first if statement. We could now copy that if statement and just do it a couple more times. 3, so we've got 1, 2, 3, 4, 5, 6, 7. So it's a case, remember, of just changing everything here. So 2, 3, 4, 5, 6, and 7. And like I said, in some ways, a range of an array would be much better here. But as I say, I like to show how the workings of a script is actually performing. So then we have the barrier, palette, blocker. So barrier, the palette, and the blocker. And then we have the barrel, spool, and container. So barrel, the spool, and finally the container. Now you'll notice that we still have our coroutine underlined red, which means there's a problem. The reason being is because we haven't had any yield within the actual coroutine. So before we get to the end of our while, and if we follow this line down, it's here. So just before we get to this close curly bracket, we need to yield, return new, wait for, let's say, seconds, and in brackets, how long we want to wait before we try and spawn the next object. So if we do it at 0.1, F, because it's a float, close bracket, semicolon, every 1/10 of a second, it will generate a new random object in a new random position. Last thing we need to do here is object quantity plus equals 1, semicolon, and save. So what's happening here is we're adding 1 to that quantity, so as this while will still function until this becomes 200 because we've added it 200 times down here. Let's head back to Unity and just make sure this compiles okay. You can see it down here, it's compiling. And there we go, no errors. Let's get rid of that queue. And let's attach this script to a new game object. So game object, create empty, and drag and drop mass gen onto there. And we just need to attach each one of those variables into their spot over here. So next is palette, and then we've got the blocker, the barrel, spool, and container. So if we actually press play now, I'm going to save my scene. If we press play now, we should be able to see this mass generate. It's also worth noting that each of these game objects over here, the brick, the barrel, whatever, they all have a box collider attached and a rigid body. So this is where the gravity comes in, so they will fall down to this ground right here. So let's press play and check out this mass randomized generation. There we go. So this will go until we have 200 objects within the scene. So if we click on game object here, we can see it's basically generating like that. So this is kind of like a cool trash pile, you could think of it. And it's going to stop right now. So there we go. we have generated 200 random objects in a random position. Excellent. And as I said, it can be used for many different things. You can also customize this to a high degree. So for example, let's generate one every 0.01 seconds, and let's have 300. So this should take 3 seconds to generate 300 objects. So let's save, head back to Unity, let it compile, and let's press play. And there we go. Perfect. So you could theoretically have that going on forever and ever and ever and ever and ever. And it's probably also worth noting that because these all have rigid bodies, if we were to get rid of the floor, which is this right here, they would all just kind of fall away. Perfect. So guys, that is how you can randomly generate in a great quantity random objects at random positions. And although it may not seem relative in some respect, it can be quite useful in many others. If you want to create a completely random area, like with random balls or something within a scene, there you go. That's perfect. So guys, I hope that's helped, and yeah, thank you very much for watching.